Transformation of functions. So this particular unit, we're going to go through taking any graph that we've ever had, the new ones from the family of functions, and we're going to start doing transformations. How do I stretch it, compress it? How do I move it up 3, down 2? All of those different transformations we're going to work on. But before we even do that, we're going to start talking about whether a function is even, odd, or neither one of those two. And we'll do it based off of its graph and based off of its equation. So let's start with the graph. Determine whether the following function is either even, odd, or neither. So from a graph, the way that we determine whether they are even, odd, or neither all comes down to what the graph looks like and its symmetry. So for an even function, it's going to be symmetric about the y-axis. Okay, for an odd function, we're going to look and determine if it is symmetric about the origin. Sorry about those first two words combining. Okay, so we take a look at the graph, and of course here's our y-axis here, here's the x-axis over here. All right, and I've got a classic parabola here, so that's my shape. So I have a quadratic function. Here's my vertex. Here's my first x-intercept. Here's my other x-intercept. We know that this thing continues onward and upward and outward from the vertex. So this is a parabola that has been transformed down, let's see, 2, 4, 5. All right, so it's been moved down 5. But it's still a regular parabola. So noticing that if I go through and I draw, I try to draw, I should say, a line that comes down through the y-axis, if I were to fold this graph in half at that y-axis, then we can see that this is actually symmetric about the y-axis. So this one here, we're looking at a function that is even. Okay, here's the first one based off of the graph. So we already know that an even function is symmetric about the y-axis. We know an odd function is symmetric about the origin, which means if I basically hold my pen here and rotate this 180 degrees, will I get the exact same graph? So if I try to take a look at this, I'm going to make an attempt to draw a dashed line that is straight, that comes down through here. That's much better than the other one so far. Whoop, until the end. Okay, so I have my graph, and I've got my line at the axis of symmetry. If I fold this thing in half, there's no way it's going to lay on top of the other side. If I hold this point here, and I rotate the graph 180 degrees, I'm not going to get the exact same graph that I started with. So when we go through and determine if this one's even, odd, or neither, it's neither, because it doesn't meet the two requirements. So it's not like a number where the number is either even or odd. Okay, this is when dealing with graphs. Even has its own qualifications, odd has its own qualifications. If it doesn't meet either one of those, it's neither. Let's take a look at the next one. All right, so this would match the family of functions that are our cubics. And if we just make sure that we extend our lines here, okay, and these go on forever. This is definitely not symmetric about the y-axis. If I fold this in half, I've got something above and something below. But if I pinpoint my marker right here, and if I were to rotate this entire graph 180 degrees, you'll see that as this rotates around, it would go right up to here. As this one rotates down, it would go right to here. So that makes this function odd. And if you have your paper, you can actually do the exact same thing. You go ahead and you hold your pen here, you spin it around 180 degrees, and if it looks exactly the same, you have an odd function. So now what about when we have an equation? We got to figure out if it's even, odd, or neither. So this one's a little, it's not complex by any means, but if I go through and I take f of negative x and I get the exact same thing in return that I started with, then that makes it even. if I take f of negative x and I get the exact opposite of what I started with, then that's an odd function. If I don't get the same thing and if I don't get the exact opposite, then it's neither one. So let's go through and we'll put a negative x in here. Okay, so let me find my marker. Here we are. So I have 1/2, and then I'm going to take negative x minus 3, square that. So I end up with 1/2. I square the first term, which gives me x squared. I take this times this, which gives me a positive 3x. I double it, so plus 6x. And then I square my last term. So this would be then, in here, f of negative x. So this doesn't equal it. So let's figure out, though, what is plain old f of x in its original form. So 1/2. I square the first term. I multiply these two and double it. And then I square the last term. All right, so you notice there's a difference here, right? So I'll point out that looking at this and looking at this, these are two different signs. It does not make the entire thing the opposite. So it's not like this. It doesn't make everything opposite, and it is not the same. So this is actually a function that is neither even nor is it odd. All right, so let's scroll down to the bottom one then. Okay, I'm going to extend the page here. So now if I go through and I substitute, so I'm not going to do anything with this. I can see what the equation is going to be. So let's take f of negative x. So 2 times the absolute value of negative x minus 1. The absolute value of a negative number is just going to give me the positive value. Okay, so then if I go through and do this, then basically it's just saying 2 times x in the absolute value minus 1. These two things are exactly the same, so therefore this is an even function. So the process by which to determine whether something is even or odd is not overly difficult. You just literally, if you take a look at the graph and determine whether it's symmetric about the y-axis, it's even. Symmetric about the origin, it's odd. If it doesn't fit either one of those, it's neither. When you go through and do the equations, again, remember that for an even function, what ends up having to be true is that if I take f of negative x, I get the exact same thing. For an odd function, if I take f of negative x, I'm going to get the entire opposite of what I started with. Those are the rules when dealing with it as equations. We've talked about the rules when dealing with them as graphs. All right, so once again, hope this was helpful. Hope this was useful. Give us any feedback in the comments, and if there are any errors that you point out, or if there's anything that you have concerns or more questions about, let us know. We can drop more information in. Thank you very much. Have a good rest of your day.